We're going to introduce Vads. Vads is a virtual aerial drone system. And I feel like they used a lot of things to put this together. I saw them working late hours all night doing their thing. So I'm going to introduce them, and they're going to let you know what they did. So this is Eric Dietz, Logan, Sammy, I'm sorry, and Jagger. There you go.
All right, well, hello and welcome everyone. We're glad that you can make it to this demo day. Today we present to you VADS, which is short for
Virtual
Aerial
Drone
Systems.
So what does our team look like? First off, I'm Eric Zick. I am the full stack expert and the UI developer.
I am Jagger Van Winkle, and I am the AR/VR expert.
I'm Sammy Ansari, and I'm the systems programmer and network engineer.
And my name is Logan Savage. I was the systems programmer and project manager.
So what is our purpose?
The aim of the VADS project is to be a seamless, intuitive, easy-to-use drone piloting and remote monitoring system that utilizes several different tools, technologies, and frameworks in order to provide a unified app for both drone hobbyists and VR enthusiasts.
So Jagger, would you like to tell us some of the features that we have?
Of course. So some of the features that we have are an Electron application featuring live data, GPS flight data, video storage, and settings management. To accompany with that, we have a Raspberry Pi that is the brains of our operation, followed by a Navio 2 hat to gather data and serial port communications. And last but not least, the fun part, the VR application that streams a live video feed into the VR headset while controlling the drone with VR inputs.
And here we have a demo video prepared.
Hi, my name is Logan, and I'm going to be going over the VADS application for you guys today. As you can see, I'm currently in the video component of the app. Down here in the bottom left, we have the user information, which is where you can log in, view your stats. Next to that, we have the start and stop recording buttons, followed by the leaderboard button. This will let you bring up all of the user's data, and you can sort from high to low or low to high. Followed by the recording button. That will bring up your 3 most recent recordings. You can either view or delete the recordings from there. In the top right-hand corner, we have the Google Maps live data, followed by the gauge clusters. Underneath that, we have the drone status that will indicate a connection, and the settings tab. In the settings tab, you can either edit or delete your user information. And from here, we're going to go ahead and go over to Jagger, where he will cover the VR portion.
All right, thank you, Logan. I am Jagger, and I'll be showing the VR application. Once you go into the application, you are greeted with a menu as well as a video feed. Within the menu, you see pitch, yaw, roll. This is all recorded in real time from the drone. The drone is communicating with the VR headset to send out real-time data as well as live video feed, demonstrated here as Sammy shakes the camera. And then you can see we have outside temps, systems temps, anything, and drone coordinates all within the headset.
All right, so Logan, would you like to explain how the process flow goes?
Of course. So to start off with, you need to make sure that you launch the VADS application, power on the drone, and then power on the VR headset. From there, the drone will establish a video stream, followed by a serial port connection to the drone for flight data and a WebSocket to the VR headset for data. Excuse me. Then the data and flight video or live video will be sent to the drone and the headset, followed by the drone receiving control commands from the VR headset.
Some of the tools and technologies that we used include C++ for serial communications and the live data management. We also used the Navio 2 C++ library for the flight controller board. We used Electron, the framework for building the application, JavaScript for the back-end operations of the app. We also used TypeScript and React for the front-end components, a Google Maps API for the GPS and positioning, Firebase and MongoDB for the user authentication, and on top of that, to extend the database, we use Raspbian, which is a customized Linux image for managing the Raspberry Pi. And then finally, C# and Unity for the VR headset experience with the heads-up display. Some of the learning objectives that we had included?
Yes, going into this project, we are excited to become acquainted with software and hardware integration techniques, especially as they relate to real-world applications, along with hands-on experience combining different programming languages and frameworks. We were also hungry to get to know more about the fundamentals of working with the Raspberry Pi. As you can see, this is our Raspberry Pi with the flight controller on top. We also wanted to learn about embedded programming best practices, and it was an essential part of this project, needing to learn how to construct them from the base components. We're thrilled to have this opportunity to evolve our skills in order to deliver the minimum viable product we're proud to present to you today.
So Jagger, how did the development and design process go?
So we met in person twice a week, Tuesday and Thursdays, followed by, if we weren't there, we'll communicate through Discord, Trello, Slack. From there, we were brainstorming how to come up with an application of some sort on Figma. We researched the data and transfer protocols like WebRTC and HLS. Setting up the VR handling to support live stream, video feed, as well as VR inputs. Setting up the Raspberry Pi and Navio to communicate with one another. Shopping for drone components to see if they're compatible. And then lastly, creating the application in Electron.
So like everyone knows, we go to a software school where hardware is not taught here. So we had a lot of challenges that we experienced. So Logan, would you tell us some of the challenges that we faced?
Yeah, I'd be happy to. So one of the big ones that we faced were drone components. We needed to make sure that we had compatible hardware. One example of this is we had an electronic speed control that was not compatible with our flight controllers. So mid-project, we had to order new ones and get those to work. And of course, we also had some shorts happening, as you can see with Eric here. And then scope of the project. So when we first started out on paper, it looked fairly simple. We quickly figured out it was a very large project, and we had to cut a bunch of features out to get it to a manageable level. And then from there, establishing as low latency as possible video connection for the camera. We experimented with different protocols like HLS and WebRTC. And then we needed to make sure that the Raspberry Pi and the Navio had as up-to-date firmwares as possible that we're still able to communicate. So that was another issue. Writing a custom serial port. So initially we started out with a WebAssembly build of an open source software. That didn't work, so then we moved over to a Mavlink protocol before eventually figuring out that that also wouldn't do what we wanted. So we settled on writing custom serial port communications and WebSockets. And then the Navio 2's actual hardware. The creators of the Navio 2 hadn't updated it since 2018, which in tech terms is a very long time. So it ended up costing us some issues. For example, we had our first camera, the lowest possible firmware was too high for the highest level of the Navio. So we had to switch to an older model to get those to communicate. And then creating the Electron app. So Electron is not something that is actually covered here at Atlas. So it's something that we had to learn as we were building it and working with it. And then getting the video feed to the VR camera. That was quite an issue. We experimented a lot before eventually settling on WebRTC.
Thank you for coming out today. You can scan this QR code to connect with us on LinkedIn and follow us on GitHub, as well as learn more about the Vads project. We look forward to seeing you next door following the presentations.
Thank you so much.
Good job, guys. Thank you.